Hello again, and welcome to this quiet corner of the cosmos. Maybe your day was long, or maybe your thoughts are still wide awake, spinning softly like the sky above. Either way, you've arrived at a moment meant for stillness. Let your breath slow. Let your body grow lighter. There's no task left tonight but rest. Tonight we drift not through noise or news, but through something much older, cosmology. Less a science class, and more a long lullaby hummed by the universe itself. It's not a lesson with answers, but a kind of stargazing for the soul. A quiet telling of what we know, what we wonder, and what still hums in the dark beyond knowing. Cosmology asks how the universe was born, how it grew, and how it might someday end. It speaks of stars and galaxies, space and dark matter, forces and patterns too vast for any one lifetime. But it also whispers something closer, that the same laws that bend starlight shaped you, that every atom in your body was forged in stars, scattered across galaxies, gathered eventually into you. You are not simply in the universe. You are of it. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tap subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. You don't need to remember everything we talk about. Let the words blur. Let the ideas fold softly into the background, like radio static from a distant star. If you fall asleep midway, that's part of the plan. The universe wasn't always quiet. It was once impossibly hot, impossibly dense, impossibly small. The Big Bang wasn't an explosion in the darkness, but the unfolding of the dark itself. A beginning that happened everywhere at once. And so, tonight, we'll let that beginning guide us. We'll move slowly, one thought at a time, as if watching stars appear in the twilight. Each idea a point of light until the whole sky begins to glow. So, get comfortable. Close your eyes if you'd like. And together, we'll step into the first story the universe ever told. If you've ever imagined the Big Bang as an explosion from a single point, a firework bursting in the darkness of empty space, you're not alone. It's how many of us first picture the beginning of the universe. A bright center, light radiating outward, a bang in the silence. But the truth is stranger, softer, more spacious. The Big Bang didn't happen at a place, but rather to space itself. It wasn't a dot expanding into the void. It was the void expanding everywhere at once. There is no center to the universe, no privileged point where it all began, no cosmic capital city from which everything spreads. The expansion didn't start from a location. It started from a state. A condition of extreme density, heat, and uniformity, where space, time, matter, and energy were so closely entwined they could barely be said to exist separately. And when that condition shifted, it didn't burst into somewhere. It became everywhere. Space didn't expand into something else. It stretched itself. It made more of itself. Imagine a loaf of raisin bread rising in the oven. Each raisin is a galaxy. As the dough expands, every raisin moves away from every other raisin. There's no special raisin at the center of the expansion. From the perspective of any raisin, all others seem to be moving outward, but it isn't the raisins doing the expanding. It's the dough itself. That's the shape of our universe. Not raisins in a void, but galaxies suspended in stretching space. This idea that the universe has no center can feel unsettling at first. We're used to things having middles, suns at the center of solar systems, hearts at the center of bodies, even cities with downtowns and roads that radiate outward. But in cosmology, this intuition doesn't hold. The universe is not expanding into something. It is not rising from a single spot. Instead, the fabric of space is expanding uniformly, and every point in that fabric is equally valid, equally central, equally not. If you stood on a distant galaxy and watched the skies from there, you'd see something astonishingly similar to what we see from Earth. Galaxies moving away in all directions, redshifted light, a cosmic background radiation glowing faintly from every corner. The expansion of the universe looks the same from every vantage point. This is one of the deepest clues that there is no center. Everywhere is the center, because there is no edge. And yet, we still carry the feeling that there must be a direction, that if things are expanding, they must be moving outward from somewhere, that if we could only go far enough, we'd reach the origin, the beginning, the spot where it all started. But there's no such place. The beginning happened in the same place you are now. It happened in the atoms of your skin, in the dust of distant moons, in the dark between galaxies. The Big Bang occurred not at a location, but to the whole of space itself. We know this not just because it's a tidy idea, but because the evidence lines up. When astronomers measure the redshift of galaxies, how their light is stretched as they move away, they find the same pattern in every direction. The farther away a galaxy is, the faster it appears to be receding. This relationship, known as Hubble's law, is exactly what you'd expect if space is expanding uniformly, not from a center but across its entire surface. No matter where you are, it looks the same. The universe doesn't privilege one location over another. Even the cosmic microwave background, the afterglow of the early universe, tells the same story. It's astonishingly uniform. No matter where you look, you see the same faint signal, the same temperature to within tiny fractions of a degree. If the Big Bang had happened at a point, we'd see evidence of that directionality. One part of the sky would look hotter, older, or denser than another, but it doesn't. It's almost eerily even, like the cooling breath of a fire that ignited everywhere. In this way, the universe hides its origins not behind distance, but behind symmetry. The more we look, the more we find the same structures, the same patterns, the same behaviors, as if the cosmos itself is whispering, "There is no middle, there is only more." And so we are left with a truth that resists our everyday instincts. We live in a universe without an edge, without a top or bottom, without a front or back. The cosmos does not stretch out like a map with a central "you are here" marker and directions to the periphery. Instead, it curves gently around us, possibly infinite, possibly finite, but unbounded. Like the surface of a balloon or the shoreless swell of a sea, you can travel forever without reaching an end. Direction, in this kind of space, becomes an illusion. Up and down mean nothing without a point of reference. Left and right are as arbitrary as the names of stars. Even outward loses meaning. We are not moving away from the center. We are moving with the expansion, like dots on a page that's being stretched. The space between galaxies grows, but the galaxies themselves stay still, caught in the flow. It's a quiet thought, but a profound one. The idea that you are not at the edge of anything, and not at the center either. You are somewhere in the middle of everywhere, a fragment of awareness, suspended in a universe that has no preferred place, no favored origin, just a continuous unfolding of space and time, of matter and energy, of questions and wonder. And yet, this absence of a center doesn't make us less, it makes us more. Because in a universe like this, every point is precious. Every star is equally part of the beginning. Every observer is looking out from the center of their own observable sphere. You, sitting here now, are as central to the story as anyone else. Not because of geography, but because of perspective. Because the universe doesn't radiate from a point. It radiates from within. So when you look into the night sky, don't look for the center. Look for the motion, for the drift, for the ancient light whispering across space that no longer needs a direction to make it meaningful. The universe has no center, but it has you. Close your eyes for a moment and imagine the beginning of time. Not a sunrise, not a ticking clock, not even a flash of light. Just the concept of time itself, unfolding for the very first time. Not because a moment arrived after another, but because there had never been moments before. There was no before the Big Bang. Not in the way we understand it, not in the way we measure experience. The beginning wasn't a moment inside time, it was the moment of time. We often ask, what came before? What existed in the emptiness that preceded the cosmos? But cosmology answers gently. The question may not make sense, because before the Big Bang, there wasn't space. There wasn't time. There wasn't a vacuum waiting to be filled. There wasn't anything at all, not in the classical sense. The Big Bang wasn't just the start of the universe. It was the origin of the very framework in which things can exist. Time, space, matter, energy. They were all bound together at the start, emerging in a single breath of reality. They didn't arrive one by one. They coalesced in a singular, inseparable event, a kind of cosmic chord, like the first ring of a bell that brings silence into sound. The laws of physics, the shape of space, the rhythm of entropy, all of it began with that transition. And from that unfolding, time began to flow. What does it mean to exist within time? To live in a universe where clocks tick, stars age, and memories are shaped by the order in which things happen. It means that everything you experience is cradled in the arms of a current that only moves forward. Time is not just a backdrop. It's the medium in which we exist. It holds every heartbeat, every rotation of the Earth, every drift of galaxies through the void. Without it, there is no motion, no cause and effect, no sequence, no story. We are creatures made of time, not just in the poetic sense, but in the physical one. The atoms in your body were once part of stars, and those stars were born from gas clouds billions of years ago. That lineage isn't just a history, it's a flow, a passage through time that led, one step after another, to you. Your thoughts move in time. Your cells age in time. You sleep and wake and breathe in cycles marked by time's slow, invisible hand. And all of this, the stars, the galaxies, the ticking of your watch, fits within a span of just under 14 billion years. That's the age of our universe. Approximately 13.8 billion years since the beginning. It sounds like forever, but on a cosmic scale, it's still young. Some stars live longer. Some processes are only beginning. The universe is ancient, yes, but not eternal. Not yet. This number, 13.8 billion, is not pulled from philosophy or poetry. It's carved out of light. We know it from the faint afterglow of the Big Bang, the cosmic microwave background, which tells us how long the universe has been cooling. We see it in the oldest star clusters, in the expansion of space, in the redshift of distant galaxies. Like tree rings, the universe bears marks of its age everywhere. And when we measure carefully, they all point back to the same thing: a beginning, a boundary, a line where the timeline starts. It's strange to think that time, something we take for granted, had a birthday. Stranger still to realize that it might also have an end. Some theories suggest that time could eventually dissolve, fade, or warp into something we wouldn't recognize. But for now, it marches forward, slow and steady, carrying everything we know with it. And if time began, what does that make us? What does that make now? It makes now something rare, something temporary. You are not floating in a boundless eternity. You are living in a sliver of cosmic history, a thin golden slice of time where stars still burn and galaxies still shine, where light still travels, where life still thinks and dreams and wonders what time even island. In this universe, the arrow of time points in one direction, from simplicity to complexity, from smoothness to structure, from a hot uniform fog to galaxies, stars, planets, and eventually to minds like yours. Why time flows this way and not the other is still a mystery, though entropy offers a partial answer. But it's more than physics. It's the reason stories make sense. It's the reason music has rhythm. It's the reason memories are anchored to the past and not the future. Time is not a separate thing that rides alongside the universe. It is of the universe. It is stitched into the geometry of space. Einstein showed us that space and time are not two threads but one. Space-time, warped and shaped by mass and energy. And so, in the presence of great gravity, time bends, it stretches, it slows. A clock on a mountaintop ticks slightly faster than one at sea level. A second near a black hole lasts longer than one on Earth. Time is not absolute. It flows differently depending on where and how you are. But all of it, every tick, every stretch, every long century or fleeting second, traces back to that origin point, when space and time came into being, when the universe began not just to expand, but to age. So when we say the beginning of time, we are not being poetic. We are being precise. There was a beginning, and we are living in its long echo. You, listening here, are part of a universe that has only existed for a fraction of eternity. You are not late. You are not early. You are right on time. Time is what lets change exist. And in that change, we find life. We find motion. We find meaning. And somewhere beyond the farthest light, the future continues to stretch open, second by second, because time, like space, is still expanding. In the deep quiet of the night sky, there is a glow you cannot see. It doesn't shimmer or flicker like the stars. It doesn't move with the planets or trace the familiar lines of constellations. It is softer than all of that, older, woven into the fabric of space itself, a whisper of warmth from a time when the universe was still an infant. This is the cosmic microwave background, the afterglow of creation, the quiet light left over from the Big Bang. It's not dramatic. It doesn't burn or dazzle, but it is everywhere. It is in the space between galaxies and in the silence between heartbeats. It moves through you now, just as it moves through stone, through water, through empty sky. You've been bathed in it your entire life. Every inch of your skin has felt its passage, even though you cannot sense it. It is not a light we can see with our eyes. It is light that has been stretched by time itself, redshifted by the expansion of space, until it no longer glows in the visible spectrum. What began as a brilliant blaze has softened into a low, invisible hum, a microwave sigh from a universe that was once impossibly young. To understand this background, we must travel back, not just to the beginning, but to the moments just after, when the universe was still hot and dense, filled with a fog of particles and radiation that bounced endlessly, unable to escape. In that early fire, photons, particles of light, couldn't travel freely. They were trapped in a plasma soup of electrons and protons, scattering again and again like echoes in a storm. The universe, for all its brightness, was opaque. But then, something changed. About 380 years after the Big Bang, the universe cooled just enough for those particles to combine into neutral atoms. Suddenly, the fog cleared. The light was free. And in that moment, when the universe became transparent, the photons streamed outward in every direction. That was the first light to travel, unimpeded across space. And it's still traveling, still moving, still here. We see it now as the cosmic microwave background, or CMB, not because it glows like a star, but because it fills the universe like a soft thermal imprint, a baby picture of everything that would come. It carries with it the fingerprints of that early time. The tiny ripples, the faint irregularities, the seeds of structure that would one day become galaxies, clusters, and the long arching threads of cosmic webbing. It is a snapshot of the universe when it was just 0.003% of its current age. A picture not taken with a camera, but painted in temperature, in tiny fluctuations, just millionths of a degree above absolute zero. When we map the CMB, what we're really seeing is the first memory the universe ever made, a memory of its own birth. A fossil of light, undisturbed for billions of years, waiting patiently for creatures with instruments and curiosity to find it. And we did. In 1965, almost by accident, two radio astronomers, Arno Penzias and Robert Wilson, detected a strange, persistent noise in their antenna. No matter where they pointed it, the hum was there. Faint, uniform, inescapable. They didn't know it at first, but they had stumbled upon the echo of the Big Bang, a whisper from the oldest sky. Since then, we've built more precise instruments. Satellites like COBE, WMAP, and Planck have mapped the CMB in exquisite detail. They've shown us that the early universe wasn't perfectly smooth, but slightly lumpy, slightly warmer in some places, slightly cooler in others. And those tiny differences, magnified over cosmic time, are what allowed gravity to pull matter together, to form stars, galaxies, and eventually the structures we see today. The CMB is not just a glow, it's a blueprint, a guidebook written in heat and time, and still, it's here, right now, filling every space you occupy. If your eyes could see microwave light, the sky wouldn't look dark. It would shine faintly with that uniform glow, a canvas of subtle speckles tracing back to the beginning. You'd see the universe not as it is, but as it once was. Not as a place of stars and planets, but as a warm sea of potential, just beginning to coalesce. There's something humbling in that, something strangely comforting. The idea that even in the dark, we are touched by ancient light. That every quiet moment is layered with a radiation older than memory, older than Earth, older than the idea of life. It asks nothing from you. It doesn't flash or demand attention. It simply continues, humming softly, reminding you that everything around you, every object, every moment, every breath, is part of a story that began long ago in a warm, glowing haze. And though the CMB is now cooled to just 2.7 degrees above absolute zero, it still holds the shape of the beginning. It still contains the scaffolding of structure. It still sings, faintly, of the moment when the universe became visible for the first time. That song is not heard with ears, but with instruments, not interpreted with words, but with equations. Yet its meaning is simple. We came from light. You are not separate from this background. You exist within it. Your atoms were once part of that hot plasma. Your time is measured in the same ticking that began when those photons first flew free. And somewhere in the quiet between now and sleep, you can imagine them still moving, still traveling, still filling the space between stars, and stirring the void with the memory of fire. It is the oldest light we can see, and it is still arriving. In the first trillionth of a second after time began, the universe did something extraordinary. It didn't just expand, it inflated, not gradually, not slowly warming into being like a sunrise, but with a force beyond imagination. In an instant so brief it almost escapes description, space itself grew exponentially, doubling and doubling again, over and over, faster than light could move across a single atom. It didn't stretch gently. It ballooned. The entire observable universe, which today spans billions of light years, was once compressed into something smaller than a grain of sand, and then, without warning, It surged outward. This was cosmic inflation, a moment when the rules we're used to, the familiar rhythms of motion and cause, were overtaken by something deeper. It's not that objects moved faster than light. That would violate relativity. No, nothing in space traveled faster than light. Instead, space itself expanded. The fabric of the universe swelled like a breath held too long, like the skin of a balloon swelling so rapidly you'd miss it if you blinked. In that brief flicker, the scale of the universe grew by an unfathomable factor, smoothing out any wrinkles, erasing any unevenness, and laying the foundation for all the structure that would follow. It helps, maybe, to picture the surface of a balloon as it inflates. Tiny marks on the surface, little dots of ink, spread apart, not because the dots themselves are crawling away from one another, but because the rubber between them is stretching. That's what happened to space. Every point moved away from every other point, not because they were traveling, but because the space between them was growing. And during inflation, that growth was not gentle. It was explosive. This expansion was so fast, so all-encompassing, that regions of space that were once close were flung beyond each other's reach. Light, even moving at its maximum speed, couldn't keep up. Places that could once share information were cut off, separated by distances so vast that their connection was lost. And yet, paradoxically, this is part of what made the universe so smooth. Because before inflation, everything was close enough to touch. Every region of space was in contact, in equilibrium, sharing energy and temperature. Then inflation spread that uniformity across the cosmos, like warm butter on an endless slice of bread. That smoothness, that uniform temperature we see in the cosmic microwave background, is one of the great clues inflation leaves behind. Without it, the universe would likely be a patchwork, lumpy, uneven, fractured. But instead, we see extraordinary consistency. Tiny fluctuations, yes, little ripples that would become galaxies. But overall, an astonishing balance. That balance is one of the signatures of inflation, a moment of stretching that ironed the wrinkles out of the infant cosmos. It's a strange thought that the largest structures we see today, superclusters of galaxies, voids that span hundreds of millions of light years, may have been born from fluctuations smaller than a proton, magnified by inflation. Quantum jitters stretched across the sky, the seeds of everything, amplified by space itself, moving outward faster than the speed of light. And yet, it didn't break the rules, because Einstein's theory of relativity places a speed limit on objects moving through space, not on the expansion of space itself. There's no cosmic policeman stopping the fabric of the universe from stretching faster than light could chase. And during inflation, that's exactly what happened. It's not an exception to physics. It's one of its most dramatic expressions. For a fleeting instant, the entire visible universe was smaller than the tip of a needle. And then, faster than any explosion, faster than light, faster than comprehension, it inflated. In less time than it takes light to cross the space between atoms, the universe became vast, not filled with stars yet, not even with atoms, just space, smoothed and chilled, waiting for the next act of creation to unfold. This moment, brief though it was, set the stage for everything. It created the large-scale structure of the cosmos. It determined the distribution of matter and energy. It shaped the gravitational landscape that would one day pull gas into stars, and stars into galaxies, and galaxies into the filaments and voids that now lace across the sky. Without inflation, the universe might still exist, but it would be unrecognizable. And still, it's not something we can see directly. We see its fingerprints in the sky, in the patterns of the cosmic microwave background, in the distribution of galaxies, in the subtle polarization of ancient light. But the event itself, the burst of exponential expansion, is hidden behind the limits of observation. We can only infer its presence, trace its edges, model its math, like hearing an echo in a canyon and imagining the shout that caused it. There is something deeply humbling about this idea that for all we can see, billions of galaxies, trillions of stars, light stretching back nearly to the beginning, it all sprang from a moment we cannot witness, a moment so brief, so total, that it transcends our capacity to truly picture it. And yet, it happened. You are here because space, for the briefest of instants, ran wild. Now, billions of years later, that inflation has slowed. The universe still expands, yes, but far more gently. Galaxies drift apart like slow dancers on a cosmic floor. The furious speed of inflation is long gone, a whisper in the deep past, but its effects remain. In every distant star, in every quiet night, in the patterns we find in ancient light. A memory, stretched across space, of the moment when everything began to grow faster than light itself. When you look up at the night sky, it's easy to imagine that you're seeing the universe. The stars scatter like diamonds across velvet, each one a sun, some with planets, some alone. You might spot a smudge of a galaxy, a cluster of stars, the soft wash of the Milky Way arching overhead, and it feels full. It feels endless, but what you're seeing is only a sliver, a luminous, visible edge of something far vaster, far stranger, because most of the universe is invisible, not hidden behind clouds, not tucked away in a corner we haven't reached yet, but fundamentally invisible. It does not shine, it does not glow, it does not emit or reflect light in any form we can detect, and yet we know it's there. Like wind in the trees or tension in the air before a storm, its presence is revealed not through sight, but through motion, through effects, through the way light bends and galaxies dance and the universe stretches itself outward. Roughly 95% of the cosmos is made of things we cannot see. Dark matter, dark energy, phrases that sound like placeholders because they are. Names we've given to the unknown. The remaining 5%. The stars, the planets, the dust, the gas, every atom in your body, that's all part of what we call normal matter. The ordinary stuff. The familiar particles. But even that small slice is wrapped and shaped by something far more elusive. Dark matter was discovered not by direct observation, but by noticing what didn't add up. Astronomers watching galaxies expected their stars to orbit in a certain way, dictated by the gravity of the visible mass. But they didn't. Stars at the outer edges were moving too fast, as if they were being held together by an invisible hand. And not just in one galaxy, but in all of them. Something unseen was contributing mass, something that added gravity without adding light. It's not just in galaxies either. Clusters of galaxies, too, move in ways that suggest far more mass than we can see. Light from distant sources bends as it passes through space, curving more than it should if only visible matter were present. This bending, gravitational lensing, is another fingerprint of dark matter, a shadow cast not by blocking light, but by distorting space itself. Wherever we look, the pattern repeats. There is more than meets the eye. Much more. We don't know what dark matter is made of. It doesn't interact with electromagnetic force, which means it doesn't absorb or emit radiation. It slips through matter and light like a ghost. But it has mass. It has gravity. It shapes the large-scale structure of the universe. Without it, galaxies as we know them wouldn't exist. Stars wouldn't have enough glue to hold together in spirals and swirls. The web of the cosmos would fray. And yet, dark matter is only part of the mystery. Even more, abundant, more, dominant, even, is something stranger still. Dark energy. It's not mass at all. It's not matter in any form we understand. It's something embedded in space itself, a kind of pressure or tension that drives expansion. While gravity pulls, dark energy pushes, And over cosmic time, that push has grown stronger. We discovered dark energy by watching distant supernovae, exploding stars that serve as standard candles, helping us measure distance across vast gulfs of space. As we looked farther and farther back in time, we expected to see the expansion of the universe slowing down under gravity's pull. Instead, we saw the opposite. The universe isn't slowing, it's accelerating. The space between galaxies is growing faster with time, not slower, and something must be causing it. We call that something dark energy, not because we understand it, but because it fills a gap in the story. It explains the acceleration. It fits the data. But like dark matter, it remains elusive, a placeholder for the unknown, a reminder that even now, with all our telescopes and satellites and simulations, we are still groping in the dark. Altogether, dark energy accounts for about 68% of the universe. Dark matter makes up another 27%. That leaves just 5% for everything else. Every star, every galaxy, every molecule of gas, every person, every planet, every thought you've ever had. Just a trace. A dusting on the surface of something vast and hidden. It's a humbling realization, one that shifts your sense of perspective. The things we build our lives around, the visible, the measurable, the tangible, are not the whole story. They are the tip of an invisible iceberg, a glint of frost in a deep, dark sea. And yet, even in that mystery, there is wonder. We may not see dark matter, but we can trace its outlines, like frost patterns on a window. We may not grasp dark energy, but we can feel its pull, gently stretching the cosmos wider with each passing moment. These forces, unseen but undeniable, are part of our world. They shape the paths of galaxies and the fate of stars. They sculpt the structure of the universe, even as we lie beneath the night sky, watching only the brightest points. Perhaps one day, we'll find what dark matter truly island. Maybe it's a new particle, a hidden field, a wrinkle in our understanding of gravity. Perhaps we'll unlock the secrets of dark energy and learn why space expands the way it does and whether it will continue forever or slow and fall back into itself. Or maybe we won't. Maybe some parts of the universe will always remain in shadow. But knowing the edges of what we don't know, that, too, is a kind of seeing, a kind of illumination. Science is not the catalog of the known. It is the exploration of the unknown, a constant turning of the page, even when the words have not yet been written. So the next time you look into the night sky and see only pinpricks of light, remember that you're gazing through an ocean of darkness, not defined by absence, but by possibility. The stars are only the story's first sentence. The rest is still unfolding, still invisible, still there. Even now, as you settle into rest and the night folds gently around you, the universe is stretching. Quietly, invisibly, it expands. Not with noise or flash, not with urgency, but with a steady, relentless grace. Galaxies drift farther apart, clusters separate. The great filaments of cosmic structure stretch ever thinner, like the strands of a web drawn across the breadth of time. And this expansion is not slowing, it is speeding up. For most of our history, we assumed that the universe's growth would eventually falter, that the outward motion sparked by the Big Bang would be slowed by gravity, tugged back by the mass of galaxies, by stars, by everything bound together. We imagined a universe that would coast to a stop, or maybe even collapse inward someday, a slow reversal back into silence. But the universe had other plans. In the late 1990s, astronomers studying distant supernovae found something they hadn't expected. These dying stars, used as cosmic mile markers, revealed that the universe was not decelerating. It was accelerating. The expansion was growing faster, not slower. And it had been doing so for billions of years. This discovery rewrote the story of everything. It implied the existence of a force we hadn't accounted for, a pressure that acts not by pulling things together, but by pushing them apart. Not like a wind or an explosion, not something that moves through space, but something deeper, an intrinsic property of space itself. We called it dark energy, a name that admits what we do not know. Dark energy is not something we can see or touch. It does not glow, it does not collect into galaxies or orbit stars, but it dominates the universe. It fills space like an invisible tide, and the more space there is, the more room there is for dark energy to act. That's the strange part. Dark energy doesn't thin out as space grows. It persists. It pushes. And as the universe expands, its influence grows stronger. This is why the expansion is speeding up. Not because of an external shove, but because space, by its nature, is becoming more and more infused with the very thing that drives it apart. It's a quiet feedback loop, a slow, inevitable widening. The more the universe grows, the more dark energy there is to stretch it further. You can imagine it like a balloon that's not only inflating, but inflating faster the bigger it gets. Not because more air is being pumped in, but because the fabric itself wants to expand. Or picture dots painted on a rubber sheet. As the sheet stretches, the dots move farther from one another. If the stretching speeds up, some dots will slip beyond sight, crossing a horizon of separation, unreachable not because they're moving fast, but because the space between you is growing too quickly to bridge. And that's exactly what's happening to the galaxies. Over time, more and more galaxies are being carried away from us by the expansion of space. Not flying away through space, but being pulled apart with it. Eventually, they reach a distance where even light, the fastest thing in the universe, can no longer make the journey back to us. Those galaxies will vanish, not in an explosion or collapse, but quietly, fading from view as the expansion carries them beyond our cosmic horizon. It's already happening. Billions of galaxies are already out of reach. Their light, emitted long ago, is still on its way, still painting our telescopes with the glow of ancient stars. But once that light arrives, there will be no more. No future signal. No way to send or receive anything. It's as if the universe is drawing curtains across the stage, one galaxy at a time, and the future holds more of the same. If dark energy continues to behave as we currently understand it, the universe will not only keep expanding, it will do so forever, faster and faster. Eventually, only the closest galaxies, those bound to us by gravity, will remain visible. The rest will slip away, leaving us in a growing island of light, surrounded by ever-deepening dark. Cosmology will become harder. The universe will seem smaller, and future civilizations may not even know what was lost. But we are lucky. We live at a moment when the light from distant galaxies is still arriving, when we can see across billions of light years and glimpse the vastness of it all. When we can watch the sky and know that what we see is only part of the picture, that there is more beyond, always more. This acceleration, as quiet as it is, reshapes our understanding of time. It means that change does not always slow with age, that even an old universe can surprise us, that stillness is not the default of time, but a temporary illusion. Beneath the silence, everything is still in motion. There is no edge to this expansion, no center, no outer wall being pushed outward, just space, growing. Galaxies not flying through the cosmos, but being drawn apart with it. Every point receding from every other. A universe not content to coast, but constantly, invisibly, stretching. And through it all, the stars still shine. They burn in their cradles of gas. They orbit in spirals. They drift in clusters. But they too are part of this motion. They are passengers in a vast, swelling sea. Even the light they emit bends under the weight of that expansion, stretched into redder wavelengths, lengthened by distance and time. In the far future, The night sky will be quieter, darker, fewer galaxies, fewer signals. But for now, we can still see it. We can still listen. We can still feel the widening of the cosmos, not as a threat, but as a lullaby of motion. A reminder that even in the stillest hour of the night, something vast and unseen is unfolding. The universe is not finished. It is still growing. Long before you were born, before your parents, before Earth took shape, before the sun even began to shine, the atoms that now compose you were already on a journey. They moved through space in silence, passing through fire and fusion, shattered and reassembled in the hearts of stars. You are made of stardust, not poetically, not metaphorically, but in the most literal physical sense. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in stars that lived and died long before the Earth was ever imagined. Stars are not just lights in the sky. They are factories, engines of creation. In their cores, under pressures so vast they defy comparison, hydrogen atoms fuse into helium, releasing energy, light, and heat. This is what makes a star shine. But the process doesn't stop there. As stars age, they begin to forge heavier and heavier elements. Helium becomes carbon. Carbon becomes oxygen. With each new stage, the star transforms, layering itself like an onion of elemental birth. In the largest stars, this progression continues all the way to iron, but iron is the end of the line. It doesn't release energy when fused. It absorbs it. So when a massive star builds up too much iron in its core, it can no longer hold itself together. Gravity wins. The star collapses inward in a fraction of a second and then rebounds in one of the most powerful events in the universe, a supernova. In that explosion, temperatures soar, matter is crushed and scattered, and in the chaos, elements heavier than iron are born. Gold, uranium, platinum. These are not formed in quiet furnaces, but in cosmic cataclysms. In death, the star becomes something more than itself. It becomes a gift. It hurls its elements into space, seeding the galaxy with the raw materials for new stars, new planets, and eventually, new life. That material drifts through space in clouds, vast, cold nurseries of dust and gas. Over time, gravity pulls these clouds together. They collapse and spin, forming disks that birth new stars, each surrounded by smaller clumps that will become planets, moons, asteroids. And in those planets, atoms find their way into oceans, into air, into trees and rocks and rivers, into skin, into thought. It took generations of stars to make you. Not one, but many. You are the end product of a cosmic lineage, a family tree of thermonuclear fusion, branching backward through time. Some of the atoms in your body may have passed through multiple stars, each one a crucible, each one a chapter in a story that stretches back over billions of years. The periodic table is not just a chart, it's a history. Each element carries the fingerprint of its origin. Hydrogen and helium, made in the first minutes after the Big Bang, are the universe's oldest ingredients. They formed before stars existed, floating in the primordial darkness. Carbon and oxygen, the building blocks of life, were created in stars like our sun, burned and shaped over eons. Iron was born in the cores of massive stars, then scattered in supernovae, and the heaviest elements, rare, precious, are whispered into being in the moments of greatest violence. You are composed of these things. You are, in a sense, an archive. Your body holds the memory of stellar lifetimes, the remnants of light long extinguished. When you move, you carry atoms that once swirled in the atmospheres of red giants. When you breathe, you draw in molecules that pass through nebulae on their way to Earth. Even the thoughts flickering in your brain are powered by chemical exchanges using particles older than the solar system itself. This is not a metaphor. It is physics. It is chemistry. It is truth. There's something deeply calming in that realization, that no matter how complex life feels, no matter how small or uncertain your place may seem, you are part of a story far older and greater than anything you could invent. You are not separate from the universe. You are made of it, not placed here, but grown here, cultivated in cosmic soil, carved from stellar light. The next time you see a star twinkling in the night, know that you are looking not just at a distant point of light, but at a cousin, a sibling, a fellow generator of atoms. And someday, far in the future, our own sun will die. It will not go supernova. It is not massive enough for that, but it will expand into a red giant, shedding its outer layers into space. It will create a planetary nebula, a glowing shell of gas, while its core becomes a white dwarf, dense, hot, and slowly fading. And in that shedding, our star will give back. It will return its processed elements to the galaxy. It will join the cycle. Someday, those atoms may help form a new star, a new world. And perhaps, on that world, life will emerge. Perhaps it will wonder, as we do now, where it came from, what it's made of. And the answer will still be stardust. Always stardust. Even in the quiet of your room, as the night deepens, you carry the weight of that legacy. Not as a burden, but as a reminder. You are the echo of stars. You are matter that dreamed of motion. You are the dust of ancient suns, gathered into the shape of a human, learning to look back toward the sky. The word everything feels final, complete. It folds around the totality of stars and planets and galaxies, and time itself like a sealed envelope. When we say the universe, we often mean all that exists, all that can exist, the whole show. But what if everything isn't everything? What if the cosmos, vast and ancient and stretching beyond the reach of light itself, is just a single bubble in a much larger sea? The idea sounds impossible, even contradictory. How could there be more than everything? But physics, especially at the edges of our understanding, has a way of whispering strange possibilities. Possibilities like this one. The universe you see, the one you live in, sleep in, dream in, may not be the only one. It may be one of many, perhaps even one of an infinite number. This idea, often called the multiverse, doesn't come from fantasy or science fiction, though it certainly fueled a great deal of both. It arises from some of our most advanced and deeply tested theories of how the universe began. It comes from inflation, quantum mechanics, and the geometry of higher dimensions. And though we cannot yet observe these other universes, the mathematics that point toward them refuses to stay quiet. One version begins in the earliest sliver of time after the Big Bang, a moment so brief it defies ordinary comprehension. In that first trillionth of a second, the universe underwent a rapid expansion called inflation. It didn't just grow, it ballooned. Space itself stretched faster than the speed of light, flattening, smoothing, and cooling as it went. Inflation explains many of the features we see in the cosmos today. Why it looks the same in every direction, why it's so finely balanced. But inflation, according to many models, doesn't stop everywhere all at once. Instead, it stops in pockets, localized zones where inflation ends and the universe settles down, like ours. But in other regions, it continues, forever, eternally, bubbling out new universes like champagne fizzing in the dark. Each bubble is its own universe, disconnected from the others by expanding space. Some might be similar to ours. Others could be wildly different. Different laws of physics, different numbers of dimensions, different forms of matter. This is called eternal inflation. It's not proven, but it fits what we know, and it suggests that our universe is not the center or even particularly special. It's just one region among an uncountable multitude, each born in the quantum foam of an ever-growing multiverse. Another version comes from quantum mechanics. The world of the very small does not behave in certainties, but in probabilities. A particle exists not in one place, but in a cloud of possible positions. It only chooses, if we can even call it a choice, when it's measured. But one interpretation of this behavior, called the many worlds interpretation, says that nothing ever truly collapses. Instead, every possibility happens, each in its own branch of reality. In this view, every quantum event is a fork, a branching path. When a particle could go left or right, it does both, one in this universe, one in another. When you make a decision, a version of you takes each path. You stay, you leave, you speak, you remain silent. Each outcome spins off a new thread of existence, unfolding its own timeline. It's not just the universe splitting, it's you, endlessly echoed, endlessly varied. And then, there are the theories that come from string theory, which posits that our universe may be a three-dimensional membrane, a brain, floating in a higher dimensional space. In that space, other brains might drift, and if two collide, they could spark big bangs of their own, birthing new universes in the aftermath. Our universe could be the result of such a collision, or one in a cycle of repeated impacts, creating cosmos after cosmos forever. These theories are not proven. They are, at this stage, speculative. Beautiful ideas, deeply rooted in mathematics, but still reaching beyond our current ability to test. There's no telescope, not yet, that can point to another universe. No equation that settles the question beyond doubt. But that doesn't mean we stop asking. Because what does it mean to think beyond everything? To look at the universe and say, maybe this is only the beginning. It means stepping outside the familiar boundaries of imagination. It means opening yourself to the possibility that the sky you see is just one window in a cathedral of windows, each revealing a different scene. It means that even the word universe might be too small, that everything may not be all their island, and that is not frightening. It's freeing, because if the universe is infinite, if reality itself is vaster than anything we can observe or touch, then we are part of something unimaginably rich. Our story is still ours, still unique, but it unfolds against a backdrop of endless variation. In that view, curiosity is not just a habit of thought. It's a kind of alignment, a way of tuning yourself to the scale of things, listening not just for the known, but for the unknown. And in the quiet, between thoughts, you might feel it, the soft suggestion of other worlds, not in the way science fiction promises, with portals or visitors or travel, but in the gentle hum beneath reality, a feeling that the universe is not a destination, but a process, not a place, but a possibility, always unfolding, always becoming. So tonight, as you rest, imagine the stars as they are, and then imagine others, untouched by our light, burning in skies we'll never see. Galaxies spinning in silence, unaware of us, and yet connected by origin. Threads in a cosmic tapestry far wider than the loom we know. Perhaps we are just beginning to understand how vast everything truly island. If you stare into the night sky long enough, your eyes begin to adjust. The stars become sharper, the outlines of trees fade into deeper shadow, and the sky takes on a texture that wasn't there before. A kind of depth. You begin to sense, without quite seeing, that the darkness isn't empty. It feels alive in a quiet, strange way, like something is gently humming behind the silence. And in a very real, very physical sense, it island. What we call space, what we think of as the black vacuum between stars, between galaxies, between atoms, is not truly empty. It is not a void, not a sterile absence. It is a stage set with invisible forces, with energies too subtle to detect without precise instruments, but present all the same. Even in the coldest, quietest corner of the cosmos, space itself is doing something. It is never still, never truly at rest. Quantum physics tells us that what we think of as nothing is, in fact, a kind of something, a restless sea of potential. The vacuum is not a dead zone, but a fluctuating field. A field filled with uncertainty, with the potential for particles to appear and vanish in fleeting whispers of existence. These are called virtual particles. They are not exactly real in the traditional sense, but their effects are measurable. They influence the world around them. They leave fingerprints on reality. Imagine looking at the surface of a still pond. From a distance, it appears perfectly flat, calm, featureless. But zoom in, and you'll see ripples, tiny waves, patterns of motion. Space is like that. With on the largest scales, it seems smooth and quiet, but beneath that stillness, at the smallest scales, it ripples with invisible activity. This quiet energy that lives in the vacuum is called zero-point energy. It exists because, in the quantum world, nothing can be perfectly still. Particles cannot have exactly zero energy, because that would require knowing both their position and momentum with perfect precision, and Heisenberg's uncertainty principle forbids that. So even the most empty space, even a volume of space stripped of every atom, every photon, every trace of matter and light, still hums with zero-point energy. It is the baseline music of the universe, and it's not just a theoretical oddity. This vacuum energy exerts real forces. It affects particles. It's the reason why certain atoms behave the way they do. It may even explain the strange repulsive force we call dark energy, which is accelerating the expansion of the universe. If dark energy is just the energy of the vacuum itself, if the fabric of space has a kind of built-in tension, then that would mean the empty space between galaxies is pushing them apart. Not with winds or pressure, but with the quiet insistence of existence itself. In this view, the universe is not expanding into emptiness. It is expanding with emptiness. The fabric of reality grows, and with it, the quiet energy that permeates it. But this idea goes deeper. According to quantum field theory, every particle is not a point, but a ripple in a field. There is a field for electrons, a field for quarks, a field for photons. And these fields are not limited to the places where particles are. They fill all of space, everywhere. Right now, you are surrounded by these fields. You are immersed in them, like a swimmer in an invisible ocean, even where there are no particles, no electrons, no light. Those fields remain. Their presence gives space its character. And in certain rare cases, we can even manipulate this seething void. One of the strangest demonstrations is the Casimir effect. If you place two uncharged, parallel metal plates very close together in a vacuum, they will slowly move toward each other. Not because of magnetism or gravity, but because the quantum fluctuations between them are slightly suppressed compared to the fluctuations outside. The imbalance creates a tiny force, a push born from the vacuum itself. This isn't science fiction. It's been measured. Emptiness, it turns out, is not nothingness. It is a reservoir, a playground, a canvas where the laws of physics express themselves, even in the absence of anything tangible. The void has structure. The void has pressure. The void has potential. And perhaps most mysterious of all, the vacuum is not constant. In the early universe, during the phase of inflation, the vacuum may have existed in a higher energy state. When that energy decayed, it released a torrent of heat and matter, a kind of controlled collapse that lit the cosmos with the fire of the Big Bang. That means the universe itself may have been born not from matter, but from a shift in the nature of emptiness. Out of the void, everything It's a humbling idea that even nothing is more than we imagined, that silence is not silence, that darkness is not darkness, that the background of all existence is not a blank slate, but a living stage, humming with invisible rhythms. So, the next time you find yourself looking up at a night sky or resting in a quiet room, remember that the space around you, the space between thoughts, between breaths, is not empty. It is rich with invisible structure, built from the deepest truths we've yet uncovered. It holds the seeds of everything that is, everything that was, and everything that might be. The cosmos doesn't need light to be alive. Even in perfect darkness, it pulses with possibility. A black hole is not a hole, not in the way you might imagine. Not a tunnel, not a tear, not a cosmic drain, swirling things into some other place. It's something stranger, more subtle, more silent. A black hole is a region of space where gravity has become so intense, so overwhelmingly powerful, that nothing, no light, no sound, no memory, can escape its grasp once it crosses a certain boundary. But that boundary isn't a wall, it's a horizon. This edge is called the event horizon. It's not a surface you'd bump into. You wouldn't feel a shiver as you passed it. You might not even notice. But from the outside, that's the last place anyone would ever see you. Once past that invisible line, all paths lead inward, toward a center that isn't really a point in space, but a destination in time. Because in a black hole, space and time are no longer separate. They twist, they fold, they collapse into each other, like paper burning into ash. A black hole is what happens when mass collapses beyond a limit. A star, perhaps, many times more massive than our Sunday, burns its last fuel, can no longer push outward against the weight of its own gravity, and begins to fall inward. It doesn't just shrink, it implodes. It becomes denser and denser until it folds itself into a single point, or something near it, called a singularity. At least, that's what the equations suggest. Our physics, so confident in most situations, begins to stutter there, to crack. The singularity is the place where gravity becomes infinite, where time and space as we know them cease to apply. It may be a point, it may be something else entirely. We don't know. We can't know. Not yet. It lies behind the curtain, behind the event horizon, where our instruments can't reach and our theories blur into contradiction. But the effects of a black hole ripple far beyond its surface. They bend the paths of stars, distort the light of galaxies behind them, even slow time. Yes, time itself runs differently near a black hole. If you were to orbit one, hovering just outside the event horizon, time for you would slow compared to someone far away. A minute for you might be hours, days, years elsewhere. It's not science fiction, it's relativity. And we've measured this effect, faint though it may be, on Earth. GPS satellites account for it every day. Inside the event horizon, time doesn't just slow. It tilts. It becomes a direction, like down. Once inside, you can no more resist falling toward the singularity than you can resist moving forward in time. That is the strange truth of black holes. They don't just trap light, they trap moments, they trap futures. Yet despite their ferocity, black holes are not violent in the way storms or explosions are. They don't suck things in. They don't hunt. You could orbit one safely if you stayed far enough away. From a distance, they behave like any other massive object. It's only up close that the strangeness begins. It's only when you get too close that the rules you once trusted begin to break. They are paradoxes, wrapped in darkness. Stephen Hawking once showed that black holes aren't entirely black. They leak. Through a process called Hawking radiation, tiny amounts of energy escape, slowly evaporating the black hole over time. It's a process so slow that it would take longer than the current age of the universe for most black holes to vanish. But it happens. And that creates a puzzle. If black holes can disappear, what happens to the information about the things that fell into them? In physics, information can't be destroyed. Not truly. But in black holes, it seems to be. That leads to one of the most enduring mysteries in science, the information paradox. If black holes evaporate, does the information they swallowed vanish? Is it scrambled on the surface? Is it encoded in the radiation? Or do we need a new understanding of physics entirely, one that merges gravity and quantum mechanics into something we don't yet possess? We don't know, and that not knowing is part of what makes black holes beautiful. They are reminders that we are still students of the universe, that there are places where our tools fall short, where our confidence falters, where mystery endures, untouched. They are also surprisingly common. Our galaxy, the Milky Way, harbors a supermassive black hole at its center, millions of times the mass of our Sunday. It sits there quietly, surrounded by stars whipping around it at incredible speeds. We've even imaged it indirectly, its shadow against glowing gas, a ring of fire bent by gravity. Other galaxies have them too, some far larger. These titans may have shaped the growth of galaxies themselves, anchoring them, stirring them into spirals. And then there are the smaller ones, the stellar black holes, scattered throughout the galaxy, invisible, unless they interact with something, unless they draw in gas, light, life. They are not rare. They are hiding in the dark, like eyes just beneath the surface of deep water, watching, waiting, silent. A black hole is not a hole. It is a place, a region where space curves inward, where time falls inward, where the very nature of here and now begins to break apart. It is not a place of death, but of transformation, a boundary beyond which we cannot yet see, cannot yet understand. But even that boundary speaks to us. In the X-rays of infalling matter, in the dancing light of distant stars, in the equations whispered by gravity. They are not monsters. They are monuments, worn down by time, shaped by physics, heavy with secrets. And maybe, just maybe, behind that horizon lies not an end, but a beginning we haven't yet learned to name. Imagine standing at the shore of an endless sea, where no matter how far you walk, no matter how many horizons you pass, you never find a wall, a fence, or a sign that says, "Here it ends." There are no cliffs to fall from, no outer walls wrapped around the stars. The universe, in all its vastness, offers no edge, no outside, just more space, more time, more of the strange, silent unfolding that has been happening since the first flicker of existence. It's a difficult concept to hold in your head, because we live in a world of edges. Tables end, roads stop, maps are drawn with borders, and we ourselves are bounded by skin, by homes, by lifespans. So when we try to picture the universe, our minds instinctively ask, what's at the end? What happens when you go as far as you can go? But the universe doesn't play by the rules of our daily geometry. It's not a sphere floating in a larger void. It's not a box sitting in a dark room. Instead, it's something more subtle and more elegant. You can think of it like the surface of a balloon, not the interior, not the exterior, just the surface itself. If you were a tiny ant crawling along that balloon's surface, you could walk forever in any direction and never find a place where it stops. You'd just keep looping around and around without ever needing a wall to mark the end. The balloon analogy is useful, but not perfect. Our universe isn't two-dimensional, and it's not necessarily curved in a way we can directly observe. But it captures something important: the idea that space can be finite in volume, yet have no boundary, no edge to reach, no outside to peer into, a shape without a shell. Still, the universe might not be finite at all. The observable universe, the part we can see, limited by the speed of light and the age of the cosmos, is just a sphere around us, about 93 billion light-years across. That's how far light has been able to travel since the Big Bang, given the expansion of space. Beyond that, there may be much more. Galaxies we will never see. Stars that have already gone dark. Entire regions of space permanently out of reach, not because they're hidden, but because the light they emit will never get here. The expansion of the universe ensures that some things are receding faster than light from our perspective. That's not a violation of physics. Space itself can expand at any speed, but it does mean that some parts of the cosmos are gone to us forever, not behind a wall, just beyond a horizon we'll never cross. And yet, as far as we can tell, there's no edge there either. The universe doesn't wrap up neatly. It doesn't announce its limits. It just keeps going. Or, perhaps, it curves subtly, quietly looping back on itself in a way that would take trillions of years to notice. Or, perhaps it is truly infinite. No loops, no curves, no ends. Just an endless stretch of possibility, seeded with galaxies, threaded with dark matter, wrapped in the quiet glow of the cosmic microwave background. If that's true, then the portion of the universe we can see is just one small patch on a far larger tapestry, like a streetlight in a vast city we'll never travel, illuminating only the fog around it. The stars above you, the galaxies in distant telescopes, the cosmic echoes we measure with satellites, all of that may be just one spark in a night without limit. There's comfort in that, in a way. To live in a universe that doesn't end abruptly, that doesn't drop off like a stage. To know that beyond the veil of distance, beyond the reach of our senses, the story continues. Not with sharp punctuation, but with quiet ellipses. And there's mystery too. If the universe has no edge, then where are we in it? Not in the center. There is no center, just as there's no edge. Every point in space can be considered the center from its own perspective. Every observer sees themselves surrounded by a horizon, just like us. The cosmos doesn't single out any place as special. Not Earth. Not our galaxy. Not even the brightest quasars in the deep field images. We are adrift in the middle of nothing in particular, and somehow that makes it all the more extraordinary. It forces a different kind of humility. Not the kind that says we're small, but the kind that says we're woven into something vast without needing to be at the center of it. That we're part of the fabric, not the seam. That existence doesn't require a frame to be meaningful. If you could travel in a straight line, forever, you'd never hit a wall. You might eventually return to where you started, if space loops. Or you might just go on, crossing galaxies, voids, and maybe, eventually, regions of space unlike anything we've ever seen. But you'd never reach a place where the universe just stops. The idea that the universe has no edge also reshapes how we think about beginnings. The Big Bang didn't happen in one spot, bursting outward into empty space. It happened everywhere at once. Space itself expanded, not into something else, but into more of itself. There was no center to that explosion, because the explosion was space unfolding. Even now, it's still unfolding. Still blooming at the edges of what we can observe, not by growing into a larger room, but by stretching the room itself. So if you've ever wondered what's outside the universe, the answer may be both simple and unsatisfying. There is no outside. The universe is all there, island, not bounded, not contained, just continuing. We live in a cosmos without borders, a place where edges are illusions and endings may never come. A universe that surrounds us not like a shell, but like an ocean with no shore. Vast, cold, full of currents we've only just begun to understand. And still, here we are, looking out from one tiny moment in one small corner, dreaming of what lies beyond our reach, and listening to the silence that stretches in every direction. When you look up at the night sky, it's easy to imagine that you're seeing it as it is now. Stars scattered across a great black canvas, flickering silently in the cold. But the truth is, stranger, You're not seeing the stars as they are. You're seeing them as they were. Every point of light that reaches your eyes is a memory, a whisper from the past, traveling across the dark. Because light takes time, and though it moves fast, faster than anything else we know, it's not instant. Light from the moon takes just over a second to reach us. From the sun, about 8 minutes. So when you watch the sunset, you're watching a moment that already happened. The warmth on your face is 8 minutes old. The golden rays sweeping across the clouds began their journey before you even stepped outside. And that's just in our neighborhood. The farther you look, the older the light becomes. The star Vega, bright and blue in the summer sky, is 25 light years away. Its glow began its journey when floppy disks were still in use and the internet was young. Deneb, high in the Northern Cross, shines from over 2,000 light years away. Its light began moving toward you before Rome fell, before books were bound, before language resembled what we speak now. And then there's Andromeda, our galactic neighbor, a faint smudge in the sky, visible only in dark places. The light from Andromeda left 2.5 million years ago. When it began its journey, early humans were just beginning to shape stone tools. There were no cities, no art, no written word, just firelight and instinct beneath ancient skies. And all that time, the light has been crossing the void, faithful, uninterrupted, just to arrive in your eyes tonight. It's like looking into a time machine, a telescope that peers not just across distance, but across eras. When astronomers study the sky, they're studying history, not just in metaphor, but in measurable, observable fact. Every image we take of a distant galaxy is a snapshot of the past, not a reflection, not a simulation, but a direct record. A delayed message carried by photons, encoded with the shape and color of a place that may no longer exist as we see it. The Hubble Space Telescope once pointed at a patch of sky so small it looked empty, no larger than a grain of sand held at arm's length. It stared for days, collecting light, patiently letting the faintest signals rise from the noise. What it revealed was astonishing. Thousands of galaxies, each a sprawling collection of stars and dust and gravity. Some of those galaxies are billions of light years away. That means their light began its journey billions of years ago, before Earth had trees, before fish had bones, before anything resembling human life had even evolved. We don't just see these galaxies, we see their childhoods. We watch them in formation, in collision, in transformation. We see some as tight knots of newborn stars, others as ancient spirals already beginning to fade. And with each photon captured, we learn something about how the universe grew, how it changed, how it became what it is now. But we never see it now. We always see it then. There's a kind of quiet magic in that. The stars you see tonight may have already changed. Some may have gone dim. Some may have died. But their light is still on the way, still in transit, crossing the vastness. The universe preserves these memories, stretches them over incomprehensible distances, and lets them arrive long after the source is gone. Light, in this sense, is both a messenger and a delay. It connects us to the past, even as it reminds us that the present is always out of reach when we look far enough away. What you see in the sky is a museum of glowing fossils, each one a fragment of a moment that has already slipped by. And if light takes time, then seeing is never instantaneous. It's always an act of translation, of reaching back. Even here on Earth, when we look at each other, the light bouncing off faces, off hands, off eyes, has traveled a small but real distance. We are always looking at what was, never quite what island, and yet we accept it. We live with it. We find beauty in it. When we look at the stars, we aren't just looking at light. We're looking at patience, at endurance, at the unfathomable resilience of photons crossing trillions of miles without faltering, without scattering into silence. They just keep going, bearing their messages, until they finally arrive. There's something soothing in that, too, to know that the universe is sending out these quiet notes of history, painting the sky not with static brilliance, but with stories, billions of years old, still unfolding above us. And there you are, lying back beneath it all, a creature of breath and warmth, catching a glimpse of time stretched thin across the night. The stars do not change for us, but we change for them. We grow old beneath their ancient glow. We make wishes. We chart seasons. We map myths onto their constellations, telling stories that last only a heartbeat compared to the age of the light itself. And in all that, there is a kind of gentle symmetry. They shine. We see. They were. We are. Tonight, when you gaze up into the sky, remember this. You are not looking at stars. You are looking at memories. You are looking at light that has traveled through silence and distance and time itself to find you. It found you. Now let it rest in your eyes. In the great silence of space, galaxies drift like islands in a cosmic sea. But they do not float alone. They are part of something larger. An unseen choreography, a delicate and vast ballet performed across billions of light years. Though each galaxy is a marvel on its own, with its spirals and storms, its glowing cores and curling arms, it is in their relationships, gravitational, subtle, eternal, that we see the deeper structure of the cosmos. Galaxies do not scatter randomly like crumbs across a table. They gather, they align, they move in great arcs and strands, caught in invisible tension. The universe is not uniform, it is threaded. Filaments stretch across unimaginable distances, linking clusters of galaxies into what scientists call the cosmic web. It's an architecture shaped not by light, but by gravity. Silent and cold, yet endlessly influential. Where the strands intersect, where matter has gently folded into itself over time, we find clusters, dense gatherings of hundreds, even thousands of galaxies bound together in gravitational embrace. These clusters are not still. They move through each other slowly, like ships crossing in the night. Some crash together in collisions that take billions of years to unfold. Some simply orbit, weaving around shared centers, drawn toward hidden masses of dark matter whose presence we infer not by sight, but by motion. We watch galaxies bend their paths around what we cannot see, like wind bending around the edge of a mountain in the dark. Within these clusters, galaxies interact in ways both violent and tender. Sometimes, a smaller galaxy wanders too close to a larger one and is slowly torn apart, its stars stretched and scattered, left behind like stardust breadcrumbs. Other times, two galaxies merge, their shapes distorted, their gas clouds colliding and triggering bursts of new stars, like a second spring erupting in the deep. In some places, galaxies pass by each other silently, changed only by the pull they feel as they drift past. An invisible handshake, never touching, always felt. This is how the universe builds complexity, through quiet motion, accumulated over time. Gravity does not rush, it does not shout, it waits. And in its patience, it sculpts the skeleton of everything we see. It pulls matter into curves and folds, into halos and halos within halos. It forms great walls of galaxies, stretching for hundreds of millions of light years, with equally vast voids in between. Regions so empty, they might hold only a single galaxy in all that darkness. If we could float above the universe, not above a planet or a star, but above all of it. If we could look down on the structure of everything, it would resemble a web, not like one spun by a spider, intricate and tight, but a vast, shimmering net stretched across the black. A lattice made of galaxies and the unseen matter between them, glowing at the nodes, dark in the strands. We are not at the center of it. There is no center. But we are within it, held by its shape, moving along one thread of its endless mesh. The Milky Way, our home, is part of a small group of galaxies called the Local Group. We share this part of space with Andromeda and a few dozen others, most of them smaller and fainter. Together, we are falling, very slowly, towards something larger, the Virgo cluster. And beyond that, both our group and the Virgo cluster are part of an even greater structure, a supercluster called Laniakea. In Hawaiian, that name means immense heaven, and it island. We didn't know this until recently. For most of human history, we thought the stars we could see made up the whole of it. Then we discovered other galaxies, then clusters, then superclusters. Each time, our idea of scale had to stretch. Each time, we had to find a new way to place ourselves in the story. And the story keeps getting bigger. What's humbling, and perhaps a little beautiful, is how gentle these structures are. They are not forged in fire, like stars. They are not explosive, like supernovae. They are shaped by the quiet pull of gravity and the slow passage of time. They are the product of subtle motion, the kind you can't feel, but can trace if you have enough patience, the kind that writes its presence across billions of years and billions of miles. And through that motion, galaxies find each other. They cluster. They dance. This is not the kind of dance you see on a stage, measured in minutes or music. It's the dance of time itself, choreographed by mass and distance, unfolding in silence. A spiral arm drawn closer. A collision predicted 1 billion years ahead. A waltz that will last longer than any single star. It's happening all around us, all the time, even now, as you listen and the world falls quiet. Perhaps the most astonishing part is that we can see it, not with our eyes alone, but with instruments, data, maps drawn from whispers of light and X-rays and radio waves. We can chart the positions of galaxies, measure their speeds, infer the dark shapes that bind them. We can look not just outward, but backward, into time, and watch the structure form. The web didn't always exist. It grew from an early universe that was smoother, simpler, more homogeneous. It grew like frost, spreading across glass, complexity blooming in the cold. That structure gave us galaxies. Galaxies gave us stars. Stars gave us planets. And planets, somehow, gave us the chance to look back and see the pattern that made us possible. Tonight, when you imagine the sky, imagine not just the stars you know, but the great filaments they belong to. Imagine the long threads of gravity connecting clusters, the galactic tides and orbits too slow for us to feel but too vast to ignore. Imagine the dance that's been happening since long before there was anyone to watch it, and feel yourself, gently, as part of it. A quiet partner in the oldest waltz of all. Somewhere in the stillness of deep time, far beyond memory or measurement, the universe will come to an end, but not like the stories we tell in myth or in dreams. There will be no final explosion, no sudden silence that descends all at once. The end of everything will be a slow and patient thing, a fading, a stretching, a vanishing into cold, or perhaps into something stranger. We don't know exactly how, but we know it will come. Cosmology, in its gentle way, doesn't speak in certainties. It speaks in likelihoods, in trajectories, in unfolding patterns drawn from observation and theory. It tells us where things seem to be going, based on where they've been. But when it comes to the final chapter, the last pages of this cosmic book, the text is still blurred. We can read the outlines, the possible endings, but not the conclusion itself. One such ending is the big freeze. In this scenario, the universe continues expanding forever, driven onward by the mysterious force we call dark energy. Galaxies drift farther and farther apart until even their light can no longer reach one another. Stars slowly die out, one by one, leaving behind white dwarfs and neutron remnants then black dwarfs, hypothetical corpses of stars so ancient they've never existed yet. Over unimaginable stretches of time, even these cold embers will decay. Protons may dissolve. Black holes may evaporate into faint whispers of radiation, and the cosmos will become a place of pure darkness, where the last photon travels endlessly, never finding a receiver. It's not a violent ending. It's a quiet one, a dimming, like the last ember in a fireplace glowing red, then black, then nothing. A universe without temperature, without light, without time that matters, just a sea of distance, expanding still, but with no one left to notice. Another possibility is stranger, the Big Rip. In this scenario, dark energy doesn't remain steady, but grows stronger over time. Right now, it causes the universe to expand at an accelerating rate. But if it continues growing unchecked, there will come a point where the expansion overpowers all other forces. Not just gravity between galaxies, but the forces binding stars, planets, even atoms. Galaxies will be pulled apart, solar systems will unravel, planets will be torn from their stars. And then, in the final moments, atoms themselves will be stretched until they are no longer atoms, until the very structure of space-time is ripped open. It's dramatic, but not immediate. Even this end would take billions upon billions of years, a slow escalation into dissolution. The universe, in this telling, ends not with a whimper, but with a scream spread out across eternity. And then there is the big crunch. In this version, the expansion of the universe eventually stops. Gravity takes over. The galaxies, once flying apart, begin to fall back inward. The expansion reverses. Everything contracts. Galaxies collide. Stars burst. Temperatures rise, as all matter and energy are compressed into a tighter and tighter space. It ends as it began. In fire, in density, in a kind of rebirth of the singularity from which all things once sprang. Some have speculated that this could lead to a new Big Bang, that the universe could collapse and rebound again and again in cycles of birth and death across eternal time, a cosmic heartbeat. But we don't know. We don't even know if such a reversal is physically possible. Current observations suggest that the expansion is accelerating, not slowing. But still, it remains one of the possibilities. A reminder that the universe might have more surprises left to reveal. There are other endings too, subtler ones. The heat death, a refinement of the big freeze, where entropy reaches its maximum and nothing interesting can happen anymore. Or vacuum decay, where a bubble of true vacuum, more stable than the space we live in, spontaneously forms somewhere in the universe and expands at the speed of light, rewriting the laws of physics as it goes. A sudden, silent transformation that leaves nothing recognizable behind. And yet, even in these endings, there is no malice, no punishment. The universe is not cruel. It simply moves, obeying the laws that govern it, unfolding as it must. We may wish for permanence, for the stars to shine forever, for memory to be kept. But the cosmos is under no obligation to preserve what we value. It carries on, indifferent but beautiful, full of structures that decay and reform in endless variation. Perhaps that is what makes it so wondrous. Its impermanence, the knowledge that we are here, now, in a moment when stars still burn, when galaxies still bloom, when the sky is still full of light. We exist in the middle of the story, not the beginning and not the end, in a chapter where questions can still be asked, where time still moves in ways we can measure, where we can speak about the future even if we'll never see it. It's possible that in the very far future, something entirely unexpected may happen. A change in physics, a new field discovered, a shift in understanding that rewrites all our models. Cosmology is humble enough to admit what it doesn't know. And yet, even in the face of such uncertainty, it gives us a framework, a way to think about time that stretches beyond our lives, our planet, even our species. We are the witnesses, the brief observers of a universe in motion. We chart its past, we trace its patterns, we dream of its future. Not because we'll be there to see it, but because we are capable of wondering. That, too, is part of the story. So perhaps the most profound truth isn't how the universe will end, but that it began at all, that it exists now, that we are here to ask these questions, wrapped in warmth, resting beneath a sky still full of stars. And when that sky goes dark, as it someday will, maybe the echo of our curiosity will still ripple through the silence. Maybe the fact that we once looked up and asked, "How does it end?" is enough to mark our place in this quiet, expanding dream. Time, that steady beat we use to pace our lives, is not as uniform as it seems. We imagine it like a metronome, clicking evenly, eternally, from one moment to the next. But out there, among the stars, time bends. It stretches. It shrinks. It behaves in ways that defy our instincts, as if it were a soft thread woven into the fabric of space itself, capable of being pulled and twisted by gravity and motion. This idea isn't fantasy. It's a deeply confirmed part of our reality. According to Einstein's theory of general relativity, gravity doesn't just pull on objects, it pulls on time. In regions of stronger gravity, time ticks more slowly. A clock near a massive planet or a dense star will move at a different pace than a clock far away in empty space. It's not just a trick of perception. It's real. The seconds themselves lengthen. The beat of time changes, depending on where you are and what surrounds you. Even here on Earth, this effect exists. It's small but measurable. Your feet, closer to the center of Earth's gravity, experience time just a little bit more slowly than your head does. Over the course of a lifetime, the difference is microscopic, fractions of a second, but it's there. If you were to live your entire life in the mountains, your body would age just slightly faster than someone living at sea level. The higher you are above a gravitational source, the faster your time flows. And this difference becomes dramatic near black holes. In their presence, gravity becomes so intense that time warps drastically. The closer you get to the event horizon, the point of no return, the slower time moves for you compared to someone watching from a safe distance. If you were able to hover just above the horizon of a supermassive black hole, you could experience minutes while years pass for others far away. You'd return to find the world changed, older, out of step with the rhythm you remembered. The same rules of physics, but a completely different tempo. It's not just gravity that plays with time. Motion does, too. The faster you move through space, the slower you move through time. This is time dilation due to velocity, another strange truth revealed by relativity. It means that astronauts orbiting Earth at high speeds on the International Space Station experience time slightly more slowly than those of us standing still on the ground. Their aging is out of sync with ours, if only by the tiniest amount. In science fiction, these ideas are stretched into tales of time travel and suspended animation, but they're rooted in the very real way the universe works. We often speak about time as a universal constant, something shared equally by all things. But the cosmos tells a different story. Time is not absolute. It's local, contextual, relative. It depends on where you are, how fast you're moving, how much mass is near you. It bends to the conditions around it. This flexibility of time doesn't make it any less real. If anything, it deepens its mystery. Time is a dimension like space. And just as we can move through space in different directions and speeds, so too does the universe allow time to flow at different rates in different places. We are not living in a universe with one ticking cosmic clock. We are living in a sea of countless clocks, each one beating its own rhythm, shaped by its environment. Imagine a galaxy. At its center, a supermassive black hole. Around it, Stars orbit in vast, graceful arcs, and far out, at the edges of its spiral arms, other stars drift in slower orbits. Within this one structure, time flows at slightly different speeds. The stars near the center, drawn in by greater gravity, experience time differently than those on the fringe. The galaxy is not just a place. It is a clock with parts that disagree on the time. Now imagine a twin, born at the same moment as you, taking a journey into space. They fly close to a black hole, circle its edge, and return years later. They step out of their ship, and though only a short time passed for them, decades have passed for you. The twin paradox, once just a thought experiment, becomes real in the equations of physics. The path through space can alter your path through time. We don't experience these effects in daily life because the gravitational and velocity differences we encounter are so small. But the universe is vast and varied, and in its extremes, these subtleties become profound. Near neutron stars, in high-speed spacecraft, in the crushing fields around black holes, time reveals its true nature, not as a constant stream, but as a river with bends and currents and eddies. And yet, within this shifting landscape, we live our linear stories. Our memories arrange events in order. Our hearts beat to a biological rhythm. Our days rise and fall with the light. Time may be flexible in the cosmos, but for us, it feels consistent. We build our meaning inside that rhythm. We age. We remember. We imagine the future. We mark the passing of moments with clocks, calendars, celebrations, goodbyes. But once in a while, it's worth remembering that time is not fixed, that the seconds we feel may be part of a broader, more fluid experience, that we are immersed in a universe where time does not march in unison, but dances, stretching here, slowing there, folding into the contours of space and speed. It's humbling to know that your life, your breath, your memories are all taking place in a pocket of time unique to your position in the cosmos. That someone, somewhere else, in another gravity well, or on a faster path through space, is experiencing a different now. And yet, across all these scattered timelines, we remain connected by the same physics, the same stars, the same universe that allows time to exist at all. So tonight, as you settle into stillness and close your eyes, know that even in rest, you are moving. The Earth spins, the galaxy turns, and space stretches beneath us. Time flows on, differently in every corner, yet always forward. A strange, beautiful rhythm, carrying us along in its cosmic dance. Imagine holding your finger up to the sky on a clear night, arm outstretched, fingertip covering a tiny portion of the heavens. Just one speck, smaller than a grain of rice. Now imagine that behind that speck, invisible to your eyes but waiting just beyond the edge of darkness, there are not stars, but galaxies, thousands of them. Each one a swirling collection of hundreds of billions of stars, planets, nebulae, black holes, and mysteries, all bundled together in silent orbits and cosmic drift. In that one narrow pinprick of sky, the universe is not sparse. It is overflowing. When astronomers point powerful telescopes like Hubble at seemingly empty patches of space, what they find is not emptiness at all. They find depth, texture, whole clusters of galaxies, faint and ancient, their light just now reaching us after traveling for billions of years. And as we've continued to look deeper, with more sensitive instruments and longer exposures, the numbers have multiplied. What was once thought to be a universe of thousands of galaxies, then millions, then billions, is now estimated to contain as many as 2 trillion. 2 trillion galaxies. Pause with that. The Milky Way, the galaxy you live in, contains an estimated 100 to 400 billion stars. That number alone is staggering. More stars than you could ever count in a lifetime. More stars than grains of sand on most beaches. And yet for every star in our galaxy, There may be 5 or 10 whole galaxies somewhere out there in the cosmos. Most of them are beyond our reach. Too faint, too far, too redshifted for even our most sensitive eyes. But they're there, spread across the fabric of space-time like dust scattered across an ancient book, each galaxy a story waiting to be read, if only we could get close enough. When we talk about this kind of scale, the numbers become so large that they lose their shape. Our brains weren't built for trillions. We're tuned for the human world. For 10 fingers, a few dozen friends, perhaps a few hundred places we'll ever visit. But 2 trillion galaxies? That's a number that doesn't sit easily in the hand. It floats. It overwhelms. It humbles. Each of those galaxies is a place, a location in the grand architecture of the universe. Some are massive ellipticals, old and bloated with stars long past their prime. Others are delicate spirals like our own, arms unfurling in elegant curves, dust lanes streaking like cosmic fingerprints. Still others are irregular, chaotic, shaped by collisions or strange forces we've yet to understand. Some are homes to black holes so vast they bend space and time around them. Others may be cradles for life, with suns that shine gently on rocky planets not unlike ours. We may never see most of them. Many are so far away that their light has been stretched by the expansion of the universe into wavelengths too long for our eyes to detect. They glow in infrared, in radio, in whispers of radiation that drift like fog across the sky. Some are hidden behind clouds of intergalactic gas. Some may have already disappeared, burned out, consumed, transformed, long before their light ever reached us. What we see is a fossil record, not of what is, but what was. We are time travelers looking into deep history, seeing galaxies not as they are today, but as they were billions of years ago, young, forming, colliding, evolving. There is something both comforting and haunting in that, to know that the night sky is not a quiet field, but a crowded auditorium, that we are not perched on the edge of a lonely cosmos, but immersed in a vast, intricate web of galaxies, each one moving through space, shaped by gravity, drawn together and pulled apart in endless, silent motion. When you gaze upward and count stars, remember that you're only scratching the surface. The stars you see belong to a single galaxy, your own. And beyond that, far beyond, are oceans of galaxies, too distant for your eyes, but still present, still glowing, still real. They make up the scaffolding of the universe, the bones of cosmic structure. They drift in clusters and filaments, connected by dark matter and time, shaped by forces we've only begun to understand. Each one contains its own sky, its own histories, its own possibilities. If you could pluck just one of those galaxies out of the dark and hold it up to the light, you'd find wonders within. Nebulae blooming with new stars, ancient suns nearing the end of their burn, rogue planets wandering between systems. Perhaps, in some, life is looking back, wondering, asking the same questions we ask, in different forms, with different words. Maybe someone in another galaxy is watching their own sky, tracing shapes in constellations, dreaming of other galaxies, of places like ours. We'll likely never meet them. The distances are too great, the speed of light too slow, the universe too vast. But the knowledge that they may be out there, that galaxies like ours are not rare but common, changes the shape of loneliness. It turns it into something softer, something connected, a quiet togetherness shared across impossible space. So the next time you find yourself under a clear sky, far from city lights, with nothing but stars overhead, imagine what you cannot see. Picture the galaxies behind the darkness. Picture the trillions of places, the endless variations of structure and story, the unknown and the unimaginable, all quietly humming in the night. They are not above you. They are around you. You are part of this richness, this abundance, this staggering expanse of cosmic being. You belong to a galaxy among galaxies, a star among stars, a moment among moments in the long unfolding story of the universe. And somewhere, beyond sight, another galaxy turns. In the beginning, the universe burned. Not metaphorically, not symbolically, but truly and unimaginably. It was a furnace of pure energy, too hot for atoms, too wild for structure, a chaotic tide of light and motion that filled every corner of space. In those first seconds after the Big Bang, everything we know was compressed and boiling, plasma without identity, temperature without context, brightness without shape. It wasn't warm, it wasn't hot. It was heat itself, unbounded, uncontained, unbearable by any standard we can compare to now. But time has a softening hand, and as the universe expanded, it cooled. Slowly, gently, like steam rising from a forgotten cup of tea left out under a night sky, the heat bled outward. The searing plasma settled into atoms. Light finally decoupled from matter and began its long, uninterrupted journey across space. The glow from those early moments has never stopped moving. It stretches with the universe, fading, reddening, softening into the background radiation we now call the cosmic microwave background. Once brilliant, now barely a whisper. The universe today is not the firestorm it once was. It is cold, not chilly, not brisk, but cosmically cold. The temperature of the vacuum that fills the spaces between stars and galaxies hovers at a mere 2.7 Kelvin. That's 2.7 degrees above absolute zero. The theoretical point where all motion ceases, where atoms freeze in place, where even time seems reluctant to pass. At this temperature, the universe is not frozen, but it is quiet, slow, faint. Everything we see, the stars, the galaxies, the warmth of life on Earth, all of it exists like candlelight in a vast, cold cathedral. The story of the universe is the story of cooling. It is the long unfolding from heat to structure, from chaos to pattern, from blinding brightness to the soft, dim glow we measure now. It is a story of entropy, the great unspooling of ordered energy into disorder, the inevitable drift from what is possible to what is probable, and from what is alive with potential to what is settled, still, and spent. But cooling does not mean dying, not immediately. In fact, it is through cooling that life and structure became possible. When the universe was too hot, it was too violent for complexity. Particles collided too often, too energetically, for atoms to form, for stars to condense, for planets to coalesce. Only by cooling could matter slow down enough to bind together, to settle into orbits, to breathe. We owe our existence to the fact that the universe is not as hot as it used to be. And yet, the cooling continues. Galaxies burn through their fuel. Stars live out their luminous lives and fade into embers. White dwarfs, neutron stars, black holes. Nebulae disperse, and gas becomes scarce. New stars are born more slowly now than they once were. In the vast future ahead, trillions of years from tonight, the last stars will flicker out. The cosmos will go dark, not in anger or catastrophe, but in silence. The universe does not end with fire, but with a whisper. Some scientists call it the heat death of the universe, though the name is misleading. It's not a final blaze, but the absence of usable energy. It's a state of maximum entropy, where everything has evened out, where differences have faded, where motion still exists but no longer has direction or meaning. A flat, cold, dark universe. Not because something went wrong, but because everything simply ran its course. In this future, the background radiation that still bathes the cosmos will cool even further, slipping toward absolute zero. The last black holes may evaporate in bursts of Hawking radiation. The remaining particles may stretch too far from each other to interact again. Time itself might become irrelevant, not because it ends, but because nothing changes enough to mark its passage. But we're not there yet. We live in a fortunate moment, suspended between the heat of the beginning and the chill of the end. Stars still shine, galaxies still swirl. Life, at least here, still stirs. The cosmic temperature is low, but it is enough. Enough for complexity, for curiosity, for minds that wonder about their place in all of this. Enough for you to lie down tonight and think about the path that led from plasma to people, from primordial fire to the gentle hum of the night. Even now, that background radiation moves through you. It passes silently through walls, through skin, through the thin shells of atoms. It does not disturb, but it is there. An echo of the fire that once was. You are surrounded by it, bathed in the glow of the ancient universe. It is not warm, but it is constant. It is the memory of creation, stretched thin by time, but never quite extinguished. There is something profoundly peaceful in this knowledge, that even in a cooling universe, there is warmth in understanding. There is meaning in the drift. And in the cold spaces between stars, in the deep silence of the cosmic background, there is a kind of lullaby, not one of sound, but of presence. A rhythm written in the falling temperature of space, a song sung by entropy, slow and soft and eternal. The universe is cooling down, and in doing so, it continues to tell its story. You are drifting now, somewhere between wakefulness and sleep, in the soft edges of the night. Outside your window, the sky folds quietly over itself, the stars scattered across it like specks of memory. And though it feels like you are just a single observer, lying here in your room with breath slowing and thoughts softening, the cosmos wraps around you in a shape more personal than you might expect. You are not on the edge of anything. You are not looking out from the periphery. You are, in fact, in the center. Precisely the center of the only universe you can ever see. Everyone island. Wherever you are in space, no matter which direction you turn or how far you peer, the observable universe stretches equally in all directions from your eyes. This isn't arrogance or illusion. It's geometry, wrapped in the limitations of light and time. The universe has had only 13.8 billion years to send its signals to you, and in that time, light has traveled outward in a sphere around your position, carrying whispers from galaxies, from stars, from the infant echo of the Big Bang itself. That sphere is vast, roughly 46 billion light-years in radius. Not because the universe is that old, but because space itself has stretched and expanded as the light traveled. And so, from your perspective, you are in the middle of a glowing sphere of ancient photons, your own private bubble of visibility, your own cosmic cocoon. But the same is true for everyone, everywhere. If someone were floating in a galaxy 10 billion light-years away, they too would see themselves at the center of their own observable universe. Their sphere would look much like yours, filled with galaxies, redshifts, and relic light. Each observer, bounded by the reach of light, becomes the center of what they can know. There is no single hub, no ultimate vantage point, only a mosaic of overlapping views, an infinite patchwork of perspectives, each valid, each limited, each centered. It's not a contradiction. It's how space-time works. The observable universe is not the whole universe. Beyond your horizon, beyond the veil of what light can reach you, lies more, perhaps infinitely more. Galaxies still forming, or already gone. Civilizations that bloomed and faded before our Earth even cooled. Entire stretches of existence that have simply not had the time to announce themselves. The cosmos is vast beyond measure, but our view is always tethered to time and light. What you see is a sphere drawn by the age of the universe and the speed of light, unfolding from your position outward. This idea, this quiet centering, is not about ego. It doesn't mean the universe is arranged for your benefit or that you're the focus of its story. Rather, it's a gentle reminder that your place is real, defined, and complete in its own way. You occupy a point in space that no one else does, and that point gives rise to your unique window into the cosmos. It means that the galaxies you see in tonight's sky are seen in no other sky in quite the same way. The angle, the light, the stretch of time between here and there. It's yours. The past those photons carry has converged only at your eyes. In this moment, the universe paints itself for you in an arrangement unrepeatable and specific, one that exists only because you do. And there's something comforting in that, isn't there? That in a universe too large to hold in mind, too old to summarize in centuries, you still have a center. Not because you're special, but because that's how visibility works. Because even in the most indifferent scales of time and distance, there are still quiet structures of meaning, spheres of seeing, moments of presence, coordinates from which experience unfolds. It also means that your vision of the cosmos is a time machine. The farther you look, the older the light becomes. A galaxy 100 million light-years away shows you what it looked like 100 million years ago. The Andromeda galaxy, soft and luminous in long exposure, reaches you from 2.5 million years ago, before humans were human. Farther still, you see the glow of galaxies forming just after the first stars ignited. And farther yet, the fog of the cosmic microwave background, the whisper of the beginning. All of it arrives in concentric shells around you, stacked like layers of memory, with you at the still center. The stars don't revolve around Earth anymore, but in this sense, the universe does form itself around your perception. Not because it's made for you, but because it is reaching you. The light is personal. The distances are real. The shape of your view is not imaginary. It is measurable, traceable, knowable. And like every center, yours is ephemeral. As you move through space, through time, so too does your sphere. If you walked to the edge of your town, or flew to the moon, or drifted across the solar system, the shape of your observable universe would remain the same, but the contents would shift slightly. Different photons, different arrivals. The center moves with you. You are always at the center of what you can see, and yet so is everyone else. It's one of the great poetic facts of cosmology that every being, no matter how far flung, is at the center of their own visible universe. That every eye brings a new sphere into being. That the night sky is never repeated, never fixed, always layered with distance and time, always watching from the middle. So as you rest tonight, and the darkness folds in around your breathing, remember that the cosmos surrounds you in a perfect circle. That your position is not lost or accidental, but defined by the reach of ancient light. That even now, photons from the edge of your horizon are arriving, softly, silently, just for you. And that in the vastness of everything, you are precisely where you are meant to be. The night deepens around you, folding like a blanket over thought, breath, and time. The world grows quiet, and in the stillness, your mind opens, not outward, but inward, and yet the journey feels the same. Out there, beyond your ceiling and the clouds and the low hum of satellites and orbiting space debris, the universe expands into a structure of staggering intricacy. Not scattered, not chaotic, but webbed and woven with form. Cosmic filaments, long threads of galaxies and matter, stretch across the observable universe like strands of something living. They connect clusters, span voids, and bind stars to a larger, unseen geometry. If you could step far enough away, so far that even clusters of galaxies appear as dust, you would begin to see it. A vast, delicate lattice, a cosmic web. Bright knots of galaxies linked by fine bridges of dark matter and gas, threading across space like capillaries of light. And then, something strange might happen, not with your eyes, but with your memory, because you've seen this before, in biology textbooks, in neural scans, in the human brain. When astrophysicists began mapping large-scale cosmic structures and laying them beside high-resolution images of neurons and synaptic networks, they noticed the resemblance, not in detail, not in function, but in form. Galaxy clusters, stretched along invisible scaffolds of dark matter, mirror the way neurons reach across synaptic space, connecting through dendritic bridges, firing signals across biochemical voids. The pattern, the scale-free complexity, the elegance of connection. It feels familiar. The brain, with its hundreds of billions of neurons. The cosmos, with its hundreds of billions of galaxies. Both embedded in a medium that supports them, invisible to direct observation, detectable only through effects and echoes. Both wired by forces that balance chaos with cohesion, and both alive with motion. Of course, there's no scientific claim that the universe is a brain, or that brains are miniature universes. The laws that guide their formation are very different. One grows through chemistry and evolution, the other through gravity and expansion. One pulses with electrochemical thought, the other hums with ancient radiation and gravitational tides. But the symmetry, oh, the symmetry. It invites reflection. It invites you to wonder why structures so vast and so small might echo one another across a chasm of scale. Why complexity finds similar forms, whether in the dust between stars or the proteins inside your skull. There is no rule that says the universe must resemble our thoughts, and yet it does, in shape, if not in purpose. It's possible that both systems, brain and cosmos, are products of a kind of natural efficiency. Networks that must connect many nodes across vast spaces tend to form in particular ways. Gravity and synapses both demand a geometry that balances cost with connectivity, and so we end up with filaments and voids, bridges and gaps, links and sparks. Or maybe the connection is only poetic, and maybe that's enough. Maybe the power of the image lies not in the science it suggests, but in the quiet message it carries. That the mind which contemplates the universe does so with a structure that mirrors what it sees. That when you look up at the stars and try to picture the shape of everything, you are using the very same patterns that make up the thing you're trying to imagine. It's a loop, a reflection, a kind of soft recursion. The brain imagines the cosmos, and the cosmos reflects the brain. Some theories, still highly speculative, even suggest that consciousness and complexity are not strictly local phenomena. That awareness, in its rawest sense, might emerge in places where structure becomes sufficiently intricate. If that were true, then in the far future, when galaxies have stretched so far apart that light can no longer bridge the space between them, perhaps some new form of awareness will emerge. Not in the brains of creatures, but in the filaments themselves. But even if it doesn't, even if the brain remains a local miracle, there's still wonder in the resemblance. You are a piece of the universe that contemplates the rest. Your thoughts, drifting now towards sleep, arise from a network that in some abstract way mimics the very universe you're thinking about. Your mind builds models of stars and dark matter and space-time, and the structure it uses to do that, the folds and firing paths of your neural web, has a shape that the universe already understands. Maybe this is just coincidence, born of physical principles and mathematical necessity. Maybe it's a kind of pattern-seeking illusion, a trick of human perception. But even illusions can be useful, especially if they help us feel connected to something larger. Because there is comfort in symmetry. There is peace in seeing yourself, even dimly, in the shapes of galaxies. And there is humility in knowing that the thoughts you use to describe the universe are themselves tiny echoes of it, that your memory and your perception and your story are not separate from the cosmos. They are of it, formed by the same laws, guided by the same unfolding. The filaments of galaxies, strung across billions of light years, do not think, but they hold the structures that one day made stars, and planets, and life, and minds. They hold the silence before the song, and so in some way, even without words, they remember. As you close your eyes tonight and drift deeper into sleep, know this: your brain is made of atoms forged in stars. The pathways your thoughts follow are shaped by rules that echo through the void, and the quiet between those thoughts is not so different from the space between galaxies. It is vast, but it is not empty. It is quiet, but it is not alone. And somewhere in that quiet, the cosmos remembers its own shape. The night has settled fully now. The hush of the world is deeper, more complete. Streetlights soften, wind quiets, and even thought begins to loosen its hold. You are no longer tangled in the rhythm of the day, no longer tethered to its tasks and noise. Instead, you float, unanchored, carried not by footsteps or momentum, but by something older, something vast and unfolding. The stars above you are still burning. Some are dying, some are just being born. Across the universe, in distant corners of time, new stars are stitching themselves into being from clouds of hydrogen and gravity's careful hand. These clouds gather in slow spirals, collapsing gently under their own weight, until something invisible tips and light spills out into darkness again. The process is slow, too slow to watch, too patient for a single lifetime, but it never stops. Even now, the cosmos is weaving brightness from the raw fabric of its own silence. Galaxies continue their long migration through space, drifting not with direction but with expansion. They're not traveling through space like boats on a river. They are space, stretching with it, riding a current, not of water, but of time. The distances between them grow ever larger, not because they flee, but because the space between them is growing. The farther they are, the faster they recede, like memories slipping into the horizon of a dream. And still, in the middle of this breathless immensity, you exist, you, with your thoughts, your questions, your heartbeat. It's easy to feel small in the face of all this, to imagine yourself as a speck within a speck, orbiting a speck, on the edge of an unremarkable galaxy in a universe of 2 trillion more. And yet, what a beautiful kind of smallness it island. Not one of insignificance, but of intimacy. Because to be here at all, to know about stars and galaxies and time, is to be part of the cosmos, not just in body, but in awareness. You are made of this universe. You are shaped by its laws. Your atoms were forged in furnaces older than language. Your breath is borrowed from supernovae, and your senses are tuned to frequencies the cosmos sings without end. And your consciousness, delicate and fleeting as it may seem, is one way the universe has found to observe itself, to notice, to wonder. That wonder is part of the becoming. The stars are still forming, yes, but so are ideas, so are futures, so are we. We are not at the end of the story. The universe is not a finished work of art, hung on the wall of existence, cold and fixed in place. It is more like a breath, still exhaling, a melody, still unfolding its final notes. It is a movement, a gesture, a question still unanswered. And you, in this moment, are within the gesture. You are not outside the universe, looking in. You are not a visitor. You are the cosmos, arranged briefly as a human, a temporary expression of ancient elements, shaped by gravity, chemistry, and time. A voice within the silence, aware of the silence, and that awareness, that ability to know, to feel, to sleep and dream beneath the stars, is itself a part of the universe, becoming something more. So tonight, as your eyes grow heavy and your breath begins to slow, know this: Everything you are is woven from the same threads as galaxies and light. You belong to this vastness. You are not apart from it. You are not lost in it. You are it. Somewhere, in the depths of a molecular cloud, a new star is kindling. Somewhere else, a galaxy is rotating silently, its spiral arms stretching like lullabies through the dark. Black holes are humming, planets are cooling, radiation is drifting, and here, in the quiet space between thoughts, you are unfolding too. The story isn't over. It may never be, and as the stars dim behind your thoughts, remember, the universe isn't just out there. It's within you too. Good night, drifting soul. Rest well, beneath a sky still becoming.